Based, and our membership includes renewable energy developers like RWE. We also have large energy users, and then public interest organizations and the law firms and engineering firms that help get these projects built. Our most important position that we advocate for is a regional electricity grid that delivers reliable, affordable, and increasingly clean energy. We don't advocate against anything, meaning we don't advocate against natural gas or nuclear or anything like that. We support an all of the above strategy because, and I'll get into this very briefly here momentarily, the energy demand growth facing not just Idaho but the region is so incredible that we can't afford really to say no to anything right now. And so that's who we are. I engage with county commissions, with the state legislature, with the State Board of Land Commissioners, and then just with public interest organizations and groups around the state that are interested in being an active part of our energy system. That's who I am. Do you guys want to introduce yourselves, and then I'll do ours?
Morning, folks. My name is Scott Risley. I'm the Senior Director of Development for the U.S. West at RWE, and we're an international company based in Germany. Our United States operations are based in Austin, Texas, and we have offices around the country. We have about, and there will see some more data on our projects that you'll see coming through, but we have in excess of 11 gigawatts of installed capacity here in the United States that we built ourselves. And I'm just presiding over bringing online another 150 megawatt solar and battery project down in Arizona. So that's the kind of work we do. And just to reassure y'all, we do not have any planned projects in your county as of right now. Not to say we wouldn't like to come in the future, but we don't have anything that's pending before your board. We're not here to tell you anything. What we'd like to do today is just help you understand what we do a little better. And for that purpose, I've brought my colleague here, David Rains, and he'll introduce himself.
Good morning again, thanks for the time. So Dave Rains, I've been in renewables about 12 years. I head up the safety division at RWE Clean Energy. One of my roles in life is I have 40 years of emergency services. I'm currently the Chief of Special Operations in Putnam County, which is just north of New York City. Again, I've been in the fire service and EMS since I was 18 years old. And I've become sort of like a resident expert in battery storage, solar and battery. Well, really why I'm here today is to answer questions, to educate. Not here to sell you on anything. I'm responsible for the development, the construction and operation of these facilities, whether it's battery storage, whether it's solar and battery, et cetera, et cetera. So, happy to answer any questions that you guys have today. If I don't have the answers, I can certainly get them to you. I have a whole wealth of folks that work in my group. And looking forward to having some good dialogue this morning, and then, be able to help you understand these technologies a little bit better.
Great. So the purpose today is to hopefully just do an informational kind of session on battery storage. As Scott said, this isn't about any particular project. They're not active here in Jerome. There's no even hint at trying to pave the way for anything. Battery storage is an important and increasingly important component of Idaho's energy system and Idaho Power service territory, of which Jerome is a part. And so, as you all work through, your energy ordinance, this seemed like a reasonably good topic to try and at least kind of have some initial coverage. So we'll start with the smaller presentation here. I'm going to do a little scene setting for you, and then David will really kind of give you the nuts and bolts. And so I'm actually going to start with a thought experiment that I do when I give these presentations to just try and help scope the challenge that Idaho Power is facing. So let's imagine it's 2023 and you're the president of Boise State University. You have just a little under 27,000 enrolled students. Your board asks you for a projection of the total amount of student beds that you're going to need over the next 20 years. That's not just the beds, that's the buildings that they go in, that's the infrastructure, the bathrooms, all of it, right? You do some projections and you estimate that you're gonna have 1.9% annual student growth over those 20 years. And what that means is that in 20 years, you'll go from just under 27,000 students to just under 39,000 students. And you'll need a little over 2,200 more beds. And again, the buildings, the bathrooms, all of it that come with it. That's a 46% cumulative increase. Now, it's 2 years later, and the board comes back, it's 2025, they come back to you and say, can you please update that plan? You do some projections and you realize that your annual student growth is going to be 2.3% for the next 20 years. Remember, 2 years earlier, you estimated it was just 1.9. Now what that means is your 2025 student enrollment is going to be 45,130 students. That's almost 3,000 additional beds. And again, the bathrooms, the buildings, the laundry facilities, all of it. That's a cumulative increase of 58.3% over those 20 years. So to recap, in 2023, you projected a 46% increase in student beds. Just 2 years later, you're now projecting a 58% increase. That's a major difference, right? What are you gonna do? How do you adapt? So what does this have to do with electricity? Well, that hypothetical is Idaho Power's reality. Those are real comparisons based on actual numbers coming from their biannual 20-year plan, which is called an integrated resource plan. Every 2 years, the PUC requires them to put together a projection for the next 20 years and a plan of how they're gonna do it with, among other things, a preferred portfolio of new energy and new transmission, everything that's designed to be both reliable and as affordable as possible. The demand growth is crazy. Between 2021 and 2025, they had a 1.9% annual growth. For these coming 20 years, they're projecting a 2.3% annual growth, and it's really front-loaded. Between 2026 and 2030, they're projecting an 8.3% annual growth. That means that the demand for 2026 to 2030, these coming 5 years, is the same as the demand they served over the previous 40 years, 40, combined. That would make Idaho Power, of all utilities in the country, the one facing the most demand growth. It is incredible what they are facing. I want to touch briefly on the economic sort of impacts of all of this, because electrons and dollars are intimately connected. There's a study that was done between 1976 and 2014 that tried to sort of estimate the correlation between GDP growth and electricity sales. And what it found was a 0.86 correlation. A 1.0 is perfect. It means if you do something, the other thing will absolutely happen. 0.86 is pretty high. Just for perspective, for humans, our height to weight ratio, that's a 0.9. Basically, if we want to generate more economic growth, we have to generate the electricity to go along with it. And if we don't generate the electricity to go with it, we stunt our economic growth. That demand growth that Idaho Power is facing over the coming 5 years, we estimate is worth between $84 and $168 million in new economic activity annually. What that means is that for each megawatt of electricity demand that doesn't get met, we risk losing out on serious economic activity in the state and stunting our growth. If you flip to the slide with the map on it, and I apologize, I printed this in black and white, but there's 2 colors there. The vast majority of what you see is Idaho Power's service territory. It's everything from the west out to the east, up until a little bit, sort of the Idaho Falls, Amen area. That is one service territory. It means all the policies that get decided by counties or the state affect everything else that's in that area. And if you go to the next slide, I've given you a list of the 24 counties that are part of Idaho Power service territory. It is 637,000 customers. This is why I show up in Jerome, it's why I go to Bannock, it's why I fought really hard in Ada, where I live, to make sure that we're open for energy development. Because the policies of each of these counties affect all of the other ones as well. Idaho Power has that incredible demand growth to achieve, and to do that, they have to bring on a lot of new generation and build some transmission. And so if 1 county or 10 counties decide that they're not gonna allow that to happen, it's all of those counties that get impacted. So with that, let me just talk one slide here about battery storage or BESS, and then I will turn it over to the guys at RWE. So this is how Idaho Power uses battery storage. In the afternoon and evenings, when demand spikes, it doesn't often align with Idaho Power's generation. And so when we need the powerhouse and that local generation isn't always enough, they can go out to markets, but markets can be really expensive to buy from. When that happens, BESS, the battery storage, acts like a pressure valve. Idaho Power will, in the morning, fill up its storage with usually solar energy, when it's super cheap to produce and super cheap to buy. And then when we hit that demand peak, they release it. And that's how they help keep rates for all of us relatively affordable. And rates are only gonna go up, by the way, the question is by how much. And so what it does is it helps maximize their least cost resources. And that's why they've installed already over 500 gigawatts of it, and why over the next 40 years they're projecting another, I think about 850, megawatts, over 850 more megawatts of it, because it is a great way to leverage the cheapest available energy generation and thereby help keep our rates low. So that's some scene setting for you. I'm happy to take questions on that. We can also do questions at the end, and then we can turn it over to RWE. Okay.
I introduced a little bit about RWE, but just to go over a couple of other things that Dave will go into the details about. We have 11 gigawatts of battery storage. It's in operation, and also, 1.1 gigawatt, and 10 projects are currently under construction. So this is something we're working with every day, and we put battery solutions in a variety of different environments. Ideally, they go best right next to a substation. That's the best place for them. It looks, you've already got electrical infrastructure there. It's handy for interconnection. We prefer those sites. But the reality of the electrical grid is that we end up being asked to build these things as infill projects, as part of, in a regular city setting. I'll give you one example. There's a battery storage, and on one side is an adult business, and on the other side is a tractor repair shop. And so we sandwiched a battery system right between those two uses. And what we did to shield the neighbors is we built walls, and they've been perfectly fine with that for commercial purposes. So batteries can end up appearing in a lot of different circumstances, and they have uses at various points in the grid. So now let me have David give you a better explanation of exactly what a battery is, how we use them, and what we build them out of these days.
Thanks, Scott. So where we're at, and I apologize, we try to connect so you can kind of see this thing, and the system won't recognize the podium. So where I'm at is what is a battery energy storage system? This is the sheet I'm on here. So we talked a little bit about it, but just let me dial it down. So what it does.
So hang on, so our IT can't get it up on the screen at all?
No, unless.
I'm working on it.
If you give me, do you have the input for that computer there? And we can just switch the input to I'll give you my laptop.
I'm using a different kind of cable.
Oh, okay.
Although I would have done that.
No problem. Just try to help. Okay.
Just making sure.
Okay, so where I'm at is what is a battery energy storage system BESS? So it's pretty simple. We take the energy from the grid. In this case, it could be from a solar or wind system, or it could be from the grid, the existing grid. purpose. So it stores energy during times of low demand. So you have now a full battery to go off of, and then it releases that energy during peak demand. Right, so two things it does. It creates grid stabilization, so it helps balance the supply. So when we go out, whether it's in Maine or in California, we're not there because we threw a dart at a dartboard and said, yep, we're gonna build here. It's because some utility says, hey, listen, we're having issues balancing our system. And we can do a couple of things. We can build gas peaker plants, we can build wind turbines, we do a bunch of things, but we need to have energy so when everybody comes home, let's say in the middle of August, and turns on their air conditioner and there's a peak, we don't have any more power to draw from, so we're gonna pull from the batteries. And then at night, or when it gets cooler, we're gonna charge those batteries, and that's science behind it, I guess, from a business perspective. The other side of it is, when you build it in conjunction with, say, solar, you can charge those batteries off that DC power from solar. So now you're not pulling off the grid, you're pulling off the sun, and you can do the same thing with wind. You can charge it off the wind. So batteries, if projects come before you guys, are either gonna be AC coupled, which means it comes in from the grid, and it's coupled with AC power that's already in those high tension lines, or it's gonna be DC coupled, which means it's coming from wind or solar. So just to kind of give you a sense, if you look at a project and they say, hey, we wanna build a DC coupled project, you're gonna say, well, where's the DC coming from? It's either gotta be wind or solar. So anyway, it stores that energy, and then you have that use, for peak and off-peak power. And then, the other side of it, they call it peak shaving, right? So that's where the dollars and cents of how to have energy that doesn't cost you, peak kilowatt hour cost. And that's the business side of it that I'm not gonna get into, but when people say, well, how do I do peak shaving? That's about getting the most cost-effective electrons through your wires by having this stored power. So, but really why we're there, whether it's again Maine or California, is grid stabilization. Somebody says, hey, we got a weakness in the grid, we need battery. And then that's why we're there. And then there's this little graph there that kind of shows what I'm talking about. You got the demand that goes up, and you got that gray box, that stored power. And that's when you're able to dispatch that power from the batteries and bring that peak back down, because you really want your line flat. And that's why we do this. That's why we have the battery storage, to balance the grid stabilization. So California back in, bless you, 2017-ish, 2015, was having rolling brownouts, and they started having rolling brownouts and blackouts, because they just didn't have enough power. So they were selecting who's gonna be affected today. So that's why you saw all that battery storage be built in the mid, between 2015, 2017. You saw a lot of power, a lot of batteries going in California to deal with that peak demand issue.
Question?
Yes, sir.
So I'll go back to your construction stuff, and then you pull off the solar when you can. So on all your pictures, I don't see any solar projects on there. Have you ever looked at putting solar as a rooftop across your facilities to charge your batteries?
Yeah, we do. So we have a couple of different. I apologize, and I can send you.
I know I'm jumping ahead.
So no, it's fine. I focused on battery storage alone, but yeah, that. So what we've done rooftop, like parking garage solar, where we have an existing structure, and we use that solar to charge the batteries.
Yeah.
We've done it where we have the solar field on top of the, let's say for instance, in a municipality, on top of the old landfill that was capped. We'll do solar and then have the battery. So the solar from, that property that can no longer be used, we'll charge the battery. Same thing with the wind. We have wind turbines where we have the wind charging the battery. We don't build, RWE does not build battery storage inside structures. We build and I'll get into why we don't do that.
It's flash charts working now.
Okay.
We wanna.
Okay.
Yeah.
I apologize.
Oh, no, apologize. I'm sorry, did I answer your question, or are you still?
No, so, I mean, so we'll look on this picture, so you say you don't build it in a building, but have you ever put like a carport over the top of them with solar stuff? Just to charge the battery?
Not over the top, but adjacent to, yes.
Okay.
Okay, and a lot of it is because, and I'll talk about plug and play, if a container goes bad, we wanna be able to just go pick it up and put another container in. So that's why, and also from a safety perspective, we don't wanna create, if there's a catastrophic failure, and I'll talk about that, we wanna make sure it's open air because we want it to self-consume. We don't want it to impact, what happened in Monterey, for any of you educate yourself on this, they had the fire, but that was in an old turbine building, right? So now they have a structural fire, right? So now they have all those gases, all those conditions in a building, we're not going there. There's a whole bunch of reasons why that doesn't make sense. And from a fire guy and chief of special ops, I'm not sending guys in there to save batteries, okay? We're not doing that. So, but we do many DC coupled systems where you're getting DC power, right? You're getting solar power into the batteries, which is truly green, right? It's truly renewable versus AC coupled, where we're doing that to balance the grid off the AC system.
Okay, thank you.
Okay?
So let me piggyback on that, so if it's not in a building that's cool, do you have heat or cooling issues when they're outside in the sun?
Yeah, so when we get into the cooling, so when I start talking about like the Tesla system or the LG system, all of them have two levels of cooling and or heating, right? The boxes are pretty robust. We're talking like 150 F ambient temperature on the ground in Nevada, not that we reach 150, but the box can sustain 150 degrees F and it also can manage -30, right? So the boxes are pretty robust, but there's primary and secondary cooling and heating. So you have your conventional HVAC system, which cools the air in the box, and then you have your liquid cooling, which jackets the batteries so that you have that secondary cooling. You want to remove the heat, because the heat is what's not our friend when you talk about charging and discharging batteries, whether it's your cell phone or your tool that you leave out in the sun and you realize, darn, it's not working now, right? Because it got too hot. So same idea. What's different, and I'll talk about what's different with battery storage, is they have a brain. We have a battery management system where your Makita doesn't, your e-bike doesn't, your phone doesn't. Your phone sort of does because it gives you that message, too hot, right? Phone's too hot, can't use it anymore. So let me dive into a little bit about state-of-the-art BESS design. So I'm on the photo where you see the open box. It's got a bunch of ones across it. So that's a picture of the Tesla. Well, I'll show you a bunch of different batteries today. So the Tesla, why aren't these things failing like we saw other batteries fail? Well, they have both active and passive fuses, which means if things get too hot, the fuses open up. If you have a situation where there's overcharge or a battery that's not conditioning right, it opens the fuses, right? So that takes away the charge and the discharge. That's important. It's also doors on the outside. There's no walk-in here. So if we go back to what happened in McMicken outside of Phoenix a few years ago, where the fireman got blasted across the battery yard, that was a walk-in battery in it. We don't do those. We don't do any walk-in battery units. These are double latched outside doors. You walk around it. Each door's got a rack there, as you can see where all the ones are, right? So they're non-walk-in enclosures. And also there's thermal roof panels. So in the event of a catastrophic failure and it builds up hydrogen gas, the roof panels will open up and release that gas, which dissipates almost immediately, right? So we don't want any kind of a buildup of heat or gas. So that's what we like about these systems. They're smart systems. And I'll get a little more into it. So we talk about design, and the next page is a little bit of alphabet soup, and so I don't want to try to dazzle you with numbers. Point being that all the batteries that we utilize. Question?
Sorry.
No, I want to be interactive. I don't want to just sit there and talk
No, I
at you.
apologize. Yeah, I gotta leave at 10:30.
Oh, I'm sorry.
That's my other question.
Well, do you have any questions you want me to answer for you?
So what do you do for containment water when it catches on fire?
Okay, so, a couple of things, so we have a robust emergency services response plan that we meet with the local fire chief, fire marshal, we build that site specific. One of the biggest things there is we don't put water on them, okay? We cool adjacent boxes, so if you have multiple boxes, multiple containers, what we're doing from the fire perspective is we're cooling adjacent containers, we're letting a container go and letting it self-consume. We wanna do that for a bunch of reasons. The hotter we burn it, the more we burn off any constituents, the plastics, the lithium, all that, we wanna let it burn out. So we're not creating that secondary hazardous materials incident, right? In the event we have somebody down, something happens, and we gotta get in there, we gotta put water on it. First of all, the containers themselves have containment, but secondarily, we build into the ESRP, we have containment on site. So if a box is in a failure mode, we deploy that containment, which is really booms and pads around it. In some cases, we build secondary containment if we're building in an area that's super sensitive, but we've only had that one time of all the units we have, because again, the boxes will maintain, so the glycol system, the box is designed to maintain, if that glycol fails, that box is designed to maintain 125% of the volume of the glycol. Okay, we're not throwing water on a burning BESS. And that's not a Dave Raines thing, that's an industry thing. That's international chiefs, state chiefs, wherever you talk to. So that's how we stay away from creating that secondary hazard. Okay, in Monterey, they had a structure fire. So the building's burning, they put millions of gallons of water on it. Now they have that secondary mess to clean up. Okay?
Yeah.
So,
So one last question,
Yep.
so, being in our rural setting, and I'll pick on us since you're making this presentation to us, I don't know if everybody can hear my question, but, so do you ever purchase, specialized equipment for the rural fire departments to?
100%. So a couple of quick things, I don't know how much you know about fire service. Okay. So when I go in, or my team goes in, we talk about thermal imaging cameras. We make sure you guys have the right number of ticks and you have the training. And we'll bring in Bullard, we'll bring in whoever you buy, we'll bring them in to make sure they're doing that training. We also look at UTVs. Do you have access? We're not bringing a tender or an engine or a ladder. We're bringing in a UTV, right? So you'll be staging, any equipment that's gotta come in. We look to make sure you have UTVs, pickup trucks, things like that. And we make that part of the fire service agreement. So we'll have a fire service agreement for a project and we'll meet with that department and the mutual aid departments and we'll say, okay, what's the need, what's the gap? And the good thing is, it takes us, like 3 years to develop a project? So we make sure by the time that we're shoveling the ground, that everybody's got their equipment. Not by the time we're pushing electrons, by the time we show up and we have a shovel in the ground, fire department will have their initial training and they'll have all that equipment that they need in the event, even if there's an event during construction, delivery of the batteries, we wanna make sure that they're ready. And we'll provide training through that emergency services response plan, right off the bat.
Okay.
And then annually, once operations takes over, we'll tabletop this annually every year.
Okay.
As personnel changes, especially in volunteer or combination departments, we know that there's a lot of change, right?
Yeah, okay, I appreciate that, and I apologize for leaving.
Oh.
I had this appointment before you guys got your appointment, so I
I
apologize.
understand how busy life is.
Thanks for being here, and that's just for your notes.
That's it, yeah.
The emergency services plan is.
We're getting into NFP 855, but NFP 855 drives. Perfect. Awesome.
Do you need a keyboard?
No, I'm just gonna scroll through the slides.
Thank you.
Here, you wanna open this up one time? Okay, so design criteria. The biggest thing, is that bottom line, where BESS systems are designed to comply with major installation codes. So regardless of what county or state we're in, we built at the highest level of code. So NFPA 855. Go back one, yeah. Thank you so much for your help. So like I said, there's all kinds of alphabet soup there, UL certifications, whatnot. So to me, the biggest thing is that UL 9540. So all the batteries that RWE utilizes across our portfolio have gone through UL testing, which means they've gone through testing, large-scale fire testing to show us what happens in the event there's a catastrophic failure, so we can build that a model for response and design. But we build to 855, which is the bottom line there, which is the Bible, I would say, for what's required, and the International Fire Code. So even if we're in a community that maybe has an old code or doesn't have a stringent fire code, we're building to that. We're not saying, oh, you don't have a code, so we're gonna give you a lesser design. We're always building to that level. Next. Okay, so let's talk a little bit about, so those are fluence cubes out of the machine. You'll see the solar behind it. So there's solar in behind it, and these sit out in the desert in Arizona. We got hundreds of them. Those happen to be fluence cubes. And I try to show you pictures today of different ones. I already spoke to the fact that it meets industry standards. So what we're really focused on now for the projects that Scott talked about that are in progress are Tesla Megapack 2XLs or the LG JF2, JF4. JF2 means it's a 2-hour battery, JF4 means it's a 4-hour battery. And what's important in all this is their lithium iron phosphate chemistry. Why is that important? And I'll get into that in a minute. But it's not the old lithium ion, it's lithium iron, and it's a phosphate. We took away the magnesiums and the cobalts. When I say we, the industry. So, and again, many of the utilities now are requiring that. They're telling us they have to be these. Okay, so we're diving a little bit into the mega packs, right? So it's got a battery management system. Why is that important? That's its brain. It's got a thermal management system. Why is that important? Because we gotta keep these things cool internally. They're 24/7 monitored. Not only is Tesla monitoring, but we're monitoring through our ops center in Texas. When we lose communication, the battery is designed to shut down. Power in, power out, opens up, and the battery goes to a static state. We're not gonna monitor, operate any of our batteries unless we have that remote shut-off capability. We have to see it, right? Because we don't have a guy sitting there in a chair watching it. So we have to be able to see it. I talked about explosion prevention.
So quick question, do you have anybody monitoring it locally?
Yeah, we would have a local ops center, but they're not there 24/7. So the ops center may be, let's for example, I'm making this up, let's say in Boise, because maybe there's multiple plants, okay? Or maybe, I'm not familiar, I'm sorry with all the geography here, but it would be within an hour. You know, so it would be within an hour, you know, is usually typically our time frame. And when we train with the fire department, when they arrive in the event there's an incident, there's a Knox box, so they have access, they have a document box, they have a call sheet. So when they get there, they'll call our operators, they have a call down list, and they'll say, okay, I'm here, and our operator will be able to tell them what's going on. But we don't go charging into these things. We handle it no different than a substation. Your fire department's not gonna go into a substation, whether they're career, volunteer, or combination. So they're standing by at the gate, they're communicating with our people. Again, of all the sites that we have operating, and we have 120 plus renewable sites in the US now, we have a whole bunch of battery sites. I can count on one hand that the fire department has come in the year. Again, this isn't something that's response intensive. Most of our responses have been for brush fires. Not that we created, but brush fires in the area of the battery, or brush fires off the highway, or something. And that's most of the situations.
And also it's true, David, that if we had like an operations center in Boise, that's backed up by our ops center, it's 24 hours in Austin.
In Austin, right? Everything is monitored 24. I'm sorry if I didn't say that. Everything's monitored 24/7 in Austin. All right. Again, that's just another view. So I talked a little bit about the chemistry. Why is this chemistry important? This is the lithium iron phosphate. So you put iron in the batteries instead of cobalt and magnesium. Cobalt and magnesium are bad for a lot of reasons. One, you can't put it out at all. Secondly, it burns at a much lower temperature. So all those batteries that were put into play early on, from 2000 on, had cobalts and magnesiums and a bunch of other metals that burn. And my first, back when I started in the fire service, one summer, I was outside the firehouse hanging out like we all did, because we were always waiting for a fire as kids. And a Volkswagen came up to the intersection, and black smoke's coming out of it, and I said, oh my goodness. And so the senior guy showed up, and someone called 911, and they pulled the engine out, and they opened up the back of the Volkswagen, and they put water on it, and the fire grew 400%. As a 17-18-year-old kid, I'm like, oh my God. Little did I know, magnesium engines. I knew nothing about that. So same principle, right? They took the magnesium and the cobalts out. So that ignition point went from 200 degrees F to 500 plus degrees F. And it's really about 700 or 800 degrees. So it's really hard for these newer batteries to go into thermal runaway, especially since we have that battery management system. Smaller footprint, we have the ventilation and the cooling, like I said, the anti-deflagration systems, which means it's not going to build up pressure. We have electrical fault protection, which is those fuses, open and close those fuses, and a battery management system that's robust. We can control the batteries in each of those doors separately. So we can, if we have a problem door number 1, we can shut that down and everything stays up and running. And again, we set it up so it's tied through a fire panel. So the fire department shows up, there's a remote fire panel at the gate, and they can see exactly what's going on. They can see the same thing that our folks can see. And not everybody does that, but we take it to that level because we want them to have that information when they arrive, even if it's a fault. So they, like it happens in the school or the library, system goes at the fault, fire department comes. We want you to be able to see that. Doesn't happen very often because we're monitoring this 24/7. And if there's a problem, we'll dispatch our folks right away, well before it gets to the point that the fire system dials out. Do something yet?
Oh, no, I was gonna say this.
And then the BMS, here it is. So I don't want to get fancy on it. It's a battery management system. It's the brain, right? So what is it looking for? It looks at state of charge. What's the health of the battery? It looks at voltage. Is it performing within the curve? Is the temperature right? Is there communication? Right? So each module, like it says, has its own BMS that's tied into that middle cabinet. And we can isolate individual modules or enclosures. The batteries that failed didn't have this. It was basically a run to fail thing, which was just the way it was designed. It needed quick power. So any of those 5 bullet points, or if any of those conditions are off, it shuts this down. Go ahead. I'm sorry.
With your projects, have you had any incidents or events?
Yeah, so we've had 2 incidents. We had an incident in Nevada where a battery module, one rack of the module, so there's batteries, there's racks, and there's modules. One went bad, it shut down. We waited 24 hours, the technician went out, rolled it out, changed it out, took the batteries off site. That was one incident. The second incident was a discharge of the fire protection system due to the fact that the filters were never put in properly on the HVAC system, so it pulled in outside dust, and it thought it was smoke, and it discharged the system, which then shut the battery down, which was kind of a good test from the standpoint that everything worked. Fire department they came out, our technicians approached the box, they determined it was a fault in the system. But we haven't had any thermal runaways. We haven't had any fires of any kind.
No lost time.
No lost time, injuries, so it's been, again, and I only can attribute it to, when I look at these other incidents, I attribute it to the fact that we had a bit of a lag we're number 3 in the industry, but we kind of waited a bit until technology had run through its first couple generations. We don't have any first generation batteries out there, right? We have second, third, and fourth generation batteries. So everything that we saw fail in California, stuff in Australia and whatnot, it was the same generation lithium-ion batteries. So I think that's part of it. Second, we put a lot into these systems, and we build them, like I said, very robust, because it's our brand. And what's different that neither of these guys, spoke to about us, is that we design, build, and operate. We're not a developer that operates and sells. They're ours. They say RWE on them when we're done. The gate says RWE, right? I come from Con Edison. Con Edison Clean Energy in New York was purchased by RWE. We have the same thing, it was all brand recognition. I don't wanna sit here and bash developers that build and sell, but the same stuff doesn't go into when you're selling it, right? I think we all recognize that. It's kinda like flipping a house. You're gonna get given the bare bones, you're not gonna go the extra mile. So these are I showed you the Teslas, these are the LGs, okay? AC linked up top, overview these, so these are AC linked batteries. They're about 23 feet long, 8 feet wide, 9 feet high, right? With this one, you have 3 units, and in each, so whether you have 20 of these or one of them, you have 3 units. You see the panels on the top, and on the end is your E panel, right? That's your brain on the end. So every 3 of these has an E panel. Again, it's got the battery management system, the thermal management system, gas detection. It's got that 24/7 monitoring, remote shut off, the explosion prevention via the active ventilation. And then again, these are all designed to those same standards I showed you, and it's got the environmental compliance where it maintains any of that cooling material. If God forbid you had a failure of your cooling loop, it's all maintained within the box with 125% capacity. In the event, we've never had any of the cooling systems leak or fail, but in the event they do, we want to make sure we're capturing that.
So how many batteries would be in a unit like that?
I'll give you an exact number when we're done, but I want to guess that there's 1, 2, 3, 4, 6. There's 8 modules. What's that? 16. Well, there's 8, 16, 24 times 12. So let's say 300. Let's say 300 batteries within those racks. I want to say it's like 100, 100, and 100. And they're dry cell pouch batteries. There's no liquid in the batteries. They're within a plastic module, so I think we'll show that in a second.
And then on any given site, about how many of those units would you have?
And that all depends on what the utility is asking us to provide. So it's based on capacity. So these are about, I want to say about 1 megawatt each, give or take. Yeah, I don't think I have that. Yeah, so it's 1 megawatts for 2 hours. So, and maybe Scott can equate that to how many homes, I don't put you on the spot, but, so when I get into the pictures at the end, I can give you kind of real.
Okay.
But we would increase the sizes. Most of what we build are 4-hour storage projects. And normally what we do is we match the total capacity. So we build a 200 megawatt solar field, we'll have a 200 megawatt 4-hour battery. So it produce 800 megawatt hours of energy that's stored on site. And we can, that's one thing we can adjust. I'm building a project right now that's got 130 megawatts of battery, but it's only got 100 megawatts of PV. As the utility could use the extra, that we're adjacent to a substation, the utility can use that extra capacity for frequency regulation, voltage modulation, things like that.
And it really is called out by what the utility is saying. We typically build in an existing point of interconnect, an existing substation, and they'll tell us, hey, this is what we need. And from an engineering perspective, to go back to your question, we try to get the maximum density of energy over the smallest footprint, right? We don't want to have these vast things, so we want to keep it within a reasonable footprint. All right, this gives you just a little bit more what I talked about. It's got its own fire alarm panel. which is NFPA 72 listed, meaning it ties right back to a remote annunciator like you would have at a school, a hospital, a building like this. This one does have a fire protection, a fire suppression system in the E-Link. It's not designed to put the batteries out. It's designed to stop an electrical fire, if God forbid there's an electrical fire in the brain. It does have gas and smoke detection. It's got the ventilation. And again, it's that LFP chemistry, lithium iron phosphate. It's gone through the safety testing from UL. The modules themselves have gone through the testing of UL 9540. You'll hear that a lot when you read about batteries. Are they tested to 9540? And that's that propagation test. You light it on fire, you let it burn, you see what happens, and I'll talk about that in a second. And then the enclosure is designed, those are actually 3 separate units, and the way they're designed is fire doesn't propagate from one to the next. So, and then again, like I said, it's got, you know, all the bells and whistles for the fire department, so you know what's going on. We talked about this a little bit already. We're gonna use the highest level of codes. The bottom line, designed to comply with major installation codes. So NFPA 55, 69, 72. 69 is the ventilation, 72 is the fire alarm, it's okay. And then the IFC is the International Fire Code. We're now, most states that are ICC building code states, you'll see the new code going into effect either this month or January 1st, depending on your legislation. We actually exceed all those codes. A lot of good changes in the International Fire Code, because now they're starting to get caught up on the batteries. They've incorporated that NFPA 855, which is the Bible on how we build these systems, into the fire code. It used to reference it. Now, I happen to sit on the code standards for ICC. We fought for 3 years to get that into the code. So code enforcement officials don't have to go and look. It's right in the fire code. All right. Again, lithium iron phosphate, can't say it enough. That's a subchemistry, more stable, higher ignition point. Our thermal management system is liquid cooling and HVAC, coolant throughout each battery module, and then you have the secondary cooling containment, like I said, so nothing's gonna leak out of the box. That's the only liquid in this whole process, is the cooling liquid. And that just gives you a kind of a close-up. You have your HVAC, you have your intake and your HVAC system, and then you have a separate chiller. When you open the door, there's a chiller hanging on the wall. When you open the door, there's a small condensing unit like you would have at home. All right, why is it minimal risk? We're monitoring for faults 24/7. It's not just checking it once in a while, sending a blip. It's live monitoring. Any of those conditions are not right, shuts it down. Single point of interface, so you're going right from the unit, right to the utility, right to us. It's not going through a third party, it's not going down the road into some other building. Fire control panel connectivity option, we have that in almost all our systems, so the fire department can see exactly what's going on, even if it's a mile away. If they say, hey, we want the panel a mile down the road, we'll put the panel a mile down the road. With remote monitoring, Tesla monitors all their units. We monitor everything. Diagnostic troubleshooting. You get that 24/7 help. And as Scott said, we got a remote operations center in Austin with a backup. In Austin as well, in the event there's an issue. And we have the ability to shut these things down remotely. It takes more time to commission some of these systems than it does build them, because we have to run it through all these failure tests. Again, I think I'm repeating myself, but this is what's important, that we're monitoring voltage, performance, temperature, and that's why we don't have incidents. If there's an issue, we shut down that module, we go out, we address it. And again, it usually happens early on. Once we break something up, it goes through its first round of charge, discharge, and if something's out of whack, it shuts down and it becomes safe. We didn't have that ability before we got to this technology. Again, this is just more from when I talked to the fire department how it works when I get into what it's detecting, what does the smoke detector do, and then what happens. I kind of walked them through the fact that the damper's open, you get the fire alarm, the HVAC shuts down, and now the electricity stops. No electricity in, no electricity out. And the idea then again is to bring the battery to that static state. This is kind of a little bit more on the explosion protection, so it's an active system. So if there's a device that says, oh, we have hydrogen in the box, or there's smoke in the box, it'll open up and it'll allow it to release. And again, we do plume studies. So when people say, well, I live, this way, or my farm's over here, my business is over here, we'll do a plume study. So we'll have a third party come in and say, okay, here's the plan, we're building the BESS here, we got a building here, we got a farm here. They'll do a plume study and say, okay, worst case, this thing goes to heck, and we have a fire, what's gonna happen with the smoke, what's in the smoke? So typically what we see in most of the studies, and I haven't seen any deviate, at 100 feet downwind, when they're monitoring for volatile organic compounds, is what the EPA, the DC, and the DEP, and everybody looks at. We're not seeing anything actionable, meaning that I don't have to have a breathing apparatus on, I don't have to have a respirator on. At 100 feet, the dissipation of those constituents breaks down, breaks down where we don't have this circle of death or cone of, so we build these things so that we have that 100-foot radius, knowing that the wind may be blowing this way, that way, whatever. But at 100 feet, we're not seeing anything actionable. Okay, so I talked about the fire testing. So when we have these hazard mitigation analysis tests, on the Teslas, the BLGs, I've gotten the opportunity to see many of them. What did I see? Flame height no greater than 2.5 feet above the cabinet, not more than 3 feet wide. Fire was contained to the enclosure and only burned half the cabinet. Propagation in another enclosure, I should have said was extremely unlikely, but it doesn't because there's firewalls between it. The exhaust system prevented any buildup, there was no explosion, there was no eruption, there was no fireball. And air quality monitoring did not detect any hazardous substances above allowable levels.
This was an intended failure.
Yeah, this is when we lit them on fire in a setting, in a parking lot setting. We set the box and we did, the third party testing did it. But that's the third party, that's what we saw. Okay. So I kind of talked about how fire safety and protection are most important factors in projects. We've never had a fire at a BESS. They're designed in accordance with 855, like I said, stringent rules. We follow whatever the local fire department wants us to do, the local fire marshal. There's no deviation there, but we need to become part of the community. We go through permit review process, even when there may not be a detailed permit review process, we'll go through that process, and do the same submittal. We'll do the same submittal even if there's no permit processing. Here's everything. Monitoring 24/7, remotely shut down, immediate notification to the fire department in the event of an incident. And we'll work closely with the fire departments. So my real calling in life is being a first responder. Secondarily, to put food on the table, I do this at a corporate level, but I've been in the fire service since I was 16 years old, and I've been an emergency manager, I've been a fire marshal, was in the building department for 27 years, and it's near and dear to me. So I created these ESRPs, I created these emergency services response plans, and they're not boilerplate, they're specific to a community. I just dealt with one in Michigan, they have 8 people in the fire department. I was just with the city of Phoenix 2 weeks ago, they have 800 people, right, in the fire department. So we build it with the mutual aid agencies, we build it with county hazmat, state OFPC, Office of Fire Prevention. So we start that early on. Even if the project hasn't been approved, we start that dialogue to make sure the fire service is comfortable. And again, We only do it because, yes, sir.
Most of the fire departments in, say in Idaho are rural. They're also volunteer. So, how do you control the fact that you only have maybe one person that you're dealing with, and he has to pass it on, to the volunteers?
Great question.
That to me doesn't seem like a very safe scenario, because the volunteers should be getting the same thing as the firefighters, especially in the beginning of this new.
So, I think I understand your question. So this is about communication out to those, how do we engage them?
And how do you, get the volunteers to train?
So we provide ongoing training very early on. For once we have a design, once we say, here's the field that's going in, or here's the piece of property, it's in this fire district, it's in the Thompson Fire District. We not only bring Thompson in, we bring in everybody that the chief says might come in mutual aid. We'll do trainings on Wednesday nights, we'll do trainings on Sundays, whatever it takes to get them comfortable, okay? We also involve the chief and or his or her, delegates to be part of that review of the project. Because again, this is no different than if we were to drop a Home Depot, a fertilizer plant, or a hospital in the fire district. They have to understand what the risks are. They have to understand, we talked about what tools they need. We wanna make sure they have all the tools in their toolbox, their proverbial toolbox.
And are they gonna be financially reimbursed by who?
So typically, we have a fire service agreement that we'll negotiate as part of this, and they'll say, you know what? I'm just gonna pull a number out of my head, we need $100,000 a year. So part of the fire service agreement would be upfront money initially, and then every year, RWE would provide funding direct to the fire department, outside the other tax implications and all that. And again, it's different based on each fire department, right? The other side of this argument is, because I could be on both sides of the table and speak to it, because I am a fire chief with a department that has limited resources. This is not response intensive, but meaning that you probably will never be out there, but we have to plan for the worst case. So we want to make sure they have the equipment and the training to do that. And I'm sorry if I'm running long. So, a couple of things, just to recap. We're gonna train the first two fire department, whoever's district is in. We're gonna train the mutual aid departments. We're gonna make sure collectively they have all the tools they need, whether it's thermal imaging cameras, whether it's side-by-side units, rush units. That training is ongoing. Every year we do training, and we have a whole team of most are retired firefighters that come out and do the training. We'll have a fire service agreement in place that'll be negotiated with the county and the fire department. They'll say, okay, we're gonna make payments of X annually, and usually the bigger payments up front, and then there's a sustainment for the life of the project. And that ensures that they have what they need, even if they use it to market and get more volunteers, or they use it to put away for an engine that they're saving for. It doesn't stipulate that, it's just to support that agency. And then we become part of the community through the ESRP. And then there's a whole bunch of other things that these guys do outside of the fire department to support the community, but specific to the fire department. And we can share a fire service agreement from another community with you. It's a public document. It's just very different, because sometimes it's a fire authority, sometimes it has to go through the county, sometimes it's direct with the fire department because they're a corporation. But the bottom line is, it's a payment because we're building additional infrastructure that they have to deal with, and we recognize that. So, I hope that helps.
Oh, yeah.
Okay. Got it. So key considerations, we talk about water. So that's another kind of a gimme. We don't want you putting water on it, but every fire chief, every fire officer likes to know that he or she has water. So we'll typically build that in work with the planning department and say, okay, we're gonna put 30,000 gallons of water out there, we're gonna maintain it, and you'll have this water. And in areas where it drops below freezing, there'll be freeze protection. We'll set up an agreement with a local water purveyor. We'll refill this thing. But the most important thing is the water's out there, outside the gate, in an area where the fire department, the mutual aid departments can go get that water for any reason, whether there's a fire on the highway with a tractor trailer, whether it's a brush fire, structure fire, that water's there 24/7 for the fire department. We've never ever used fire protection water that we built for a BESS fire. Just never had, but it's there, and that's a big thing. The fire departments love that, because typically this is like outside of town, and they don't have hydrants, they don't have streams, they don't have ponds. Plus, in a community like this where you get freezing many months out of the year, this water is ready to go, and 30,000 is a lot of water. That's typically where we're capped, anywhere from 10 to 30, but 30,000 is good. It's a really good number.
Is that water that you haul in, or water that you would drill a well, or?
Typically, we don't drill wells. Typically, we contract with a purveyor, a local, to say, hey, if it's used, we need you to fill it back up, and we pay that bill.
We have used on-site wells when they're already there.
Yeah.
We use retired ag land, so occasionally we'll have a water well that we can use.
Sorry, just go back one more step, sorry, I just wanna make sure I hit that. Sorry, I apologize. So we talked about training, road access, talked about the step-by-step process. So the ESRP, excuse me, is a step-by-step process to respond to any medical emergencies, electrical emergencies, flooding, tornadoes, hurricanes, things like that. And we have a very robust operations team, and our operations folks are all trained to deal with these emergencies. They're, whether it's wind, solar, battery combination, they're all trained to the incident command level. Okay. All right, so I just want to share this with you. We have many communities that are concerned with wildfire. One of the things that we do, we have a whole bunch of third parties that'll come in and do independent wildfire studies. So I just gave you an example here. We don't have to dive deep. My point is that we go in, and we identify any areas of concern, whether it's ag land, whether it's high timber, low timber brush. This is part of really early in the game. We'll identify, hey, the site is here. Here's the box, and here's the study. So that way, people that live outside of that, people that may live along, in this case, Route 20 or Route 16. Hey, what happens if you have an incident? How is this going to impact me? And should we move this thing? Should we remove some of the vegetation? We also have a very, very robust vegetation management plan built into our operations budget. So we like to get, you'll see it in the photos, we like to keep it, it's not golf course level, but we like to keep it real low. But I just wanted to share that we spend a lot of money on wildfire, especially what's happened in California, Idaho, other places. I know it's a thing. I used to jump. After 9/11, I did a bunch of jumps out this way, and I know how devastating it is. That's just more, again, this just talks about the conditions and what the report kind of looks like when you get it. Again, we dial in the insurance piece and the analysis, and I just wanted to just let you know we do that. Okay, so here's stuff. This is real stuff. We just built this stuff. So here's Ventasso. This is California, San Diego area. There's a substation. In this case, we built the substation, right? We have a wall between the substation and the batteries, and there's your batteries, right? There's those are the LG JFs. Little different model, but same technology, same thing. So want to just kind of share that. That if you go, it's kind of in a busy area. There's a bath center next door, the school on another side, but that's the project. And then the power goes north, or it goes across the street. So it goes right across into a PG&E is the SDG&E, San Diego Gas and Electric, and it ties right into their substation. And then they'll regulate it. They'll take power. They'll pull power. They'll charge the battery, like we talked about. So these are AC coupled batteries, and this helps to balance. There's been a ton of development in this area. This helps to balance that grid.
How much energy would this store?
That one's, I'm sorry, that one's, you wanna speak to that?
That's 50 megawatt hours for 4 hours of storage, so it's 200 megawatt hours. 50 megawatts is about enough to run a very small town or a neighborhood. And the battery here provides, this is really the value here, because that amount of battery storage can provide voltage support and frequency regulation for a much larger area. And those are the things that keep your technology from crashing on you and your TV from burning out. So power quality is a huge issue for utilities, and the longer duration battery you have, the better it is for those kinds of things.
So this also, you can continue to build on it?
You can, it's scalable if you wanted to, there's obviously no room here.
This one's not, but
Yeah.
you could phase
You
it.
could plan for future growth.
You sure could. Yeah, like a system like this, you could scale it up to.
To the point that the off-taker can handle that much power, right? It's always based on the calculation of what the utility can handle, right?
I was visiting with a gentleman from Vista Utilities, Northern Idaho, and they were looking at 50 to 100 hour storage that they were interested in. So you're exactly right, these things just can scale significantly.
Are you concerned that an incident could take out your substation?
I think as David described, if there's a fire, say, in one of these units, it's gonna be confined to this unit. And you've got, number one, this wall here that will protect the substation, but the fire suppression system should confine the fire to just that particular unit and maybe damage some of the area around it.
I'm more worried about the transformer failure in the substation here. The wall's there, and it's the walls, there's stuff on the other side of the wall, right? So we're not worried about the batteries encroaching on the substation. We're worried about, God forbid, there's a substation failure. The heat and the energy generated there, we don't want impacting batteries. That's why that wall's there, because the footprint here was really limited. This is not, it's a great result, but I wouldn't, if we had to pick this spot again, we wouldn't pick this spot. It's just too small, right? So we put the fire rated wall in, it met the city, this is a city alcohol. It's very industrial. There's a lot of these walls that separate, areas, but that wall we see down the middle is really, in the event there's a catastrophic failure, that main transformer right there, we don't want that heat, that energy being transferred to the batteries.
I don't want to be pessimistic, but what about explosions?
Like the substation exploding?
Well, would batteries explode?
No, they're designed not to explode. There's nothing in them that can combust in that fashion, in an explosive fashion. And the suppression system is designed to keep the heat and the fire contained to one particular unit, and then also to contain that unit within its larger facility. And then there are internal fire suppression systems, cooling systems that go to work on it. And there's really nothing that can build up. And as Dave pointed out, it's got the units on the top that pop open if there's a buildup of gas. So the gas automatically vents. So the chances of explosion, I think, Dave.
Yeah, we've never been able to force one to explode. It's just they're not sealed containers. They don't have that ability to build up pressure. They will vent, and you'll get 2.5 feet of flame out the top of them. We've seen it. We've forced it to do that. So, again, I just wanted to give you a sense. This one just went online. It's operating really well. School right on this side, there's a big school over here. Oh, God. So this one's a little bit bigger. This has got a lot more space. This is out in Stone Ridge in Thorndale, Texas, not too far from our Austin office. So you see 2 substations here. The one on the right is the existing substation for the utility, right? They got multiple circuits. You can tell by the goalposts, right? You got multiple circuits there. And then that's our switch yard that we built. So that takes the power from the batteries into their substation. And those lines that cut across, usually you'll see 3 of them, they'll cut across. So that's typical, right? We had no control over what was there. So what was there was that substation. And that's kind of the, if we build it, you will come type thing. That's our point of interconnect, right? And then that's their high tension wires that were already existing. there, so.
This is a lot more like what you would see in a county like Charlotte or rural location.
So the way it works here, you have the batteries, and then an inverter transformer. So it'll transform the power to usable power, and this goes underground and it pops up over here. So you got all these circuits, it goes underground and it pops up over there. So the utility will say, hey, we need it at 13.8 or 69 kilovolts, and those inverters will then send that power over. We regulate it here to make sure it's all clean, and then we send it over, and then it eventually goes into the grid. So that's kind of how that works. Fenced-in enclosure, you can see we created fire department access all the way around, down the middle as well. All our fire access roads are minimum 20 feet wide. We have the luxury of being able to do a lot more. We have lighting throughout, and the spacing is double of what the code requires, right? Because we were able to do that, so we spread them out more. Helps us from a maintenance perspective, also makes it safer in the event there is an incident.
About how many acres would that encompass right now?
That is probably about 20 tops. And I'm speaking of probably the BESS yard plus the switch yard. Those together would be about 20.
Something like that would, so if a farmer sold, say, hey, you gotta have at least, well, you'll have more than 20.
Yeah.
You need more than 20 for sure.
You bet. Our rule of thumb is anywhere between 6 and 8 megawatts per acre. So if you're gonna get 50 megawatt site, multiply that times 6, I'll need 300 acres. And then I'll tack on another 20 for my S yard, switch yard. And this is. You're
gonna go crazy now.
So,
Yeah, laydowns all the way up top.
When
You see the cars.
construction
Yeah.
side,
Which
it's
is
all
now,
over
which
here.
is now just empty. We returned it back to the way we found it.
So we're running into our next appointment.
Okay.
Yeah,
But it's with P and Z, so we can be a little bit late, I think, but
And
I
just,
want to make
this,
sure that
this,
we've got time for
yeah,
our questions too.
okay, real quick, this one is really cool. This is Sulphur Springs. This was a linear piece of property, right? So this was narrow, those lines existed on the right. There's a much smaller substation there, and there's the batteries. Those are the JF2s, or JF4s up there. So you'll see the smaller containers, and they're set up more linear with the inverters in the middle, the three and three inverters, just to try to give you another sense of what we're talking about. Go ahead, next. And this I just want to share real quick. So we do a lot of single box. This one happens to be in a middle school, same technology, single box with the inverter and then the switch that goes up, up into the pole. Go ahead. And then, there's another one at our community center. This is really close to what used to be my New York office. That's a Tesla. And again, you would just multiply this by whatever. This is up in Stillwater, New York. The Hudson River is right behind it. This is a small village. They were having a lot of issues where they were getting voltage drop, especially in the summer. So NYSEG, New York State Electric and Gas, had us put a unit in. That's just over 1 megawatt, and that's at UMass Amherst. We have a whole bunch of these, and we did. The gentleman that had to leave. What we did in Amherst, we covered all the parking garages with solar panels, and the solar panels feed the batteries. So that was kind of pretty creative. Plus, it gave the students and faculty a place to park under in New England when they get all that snow. And that's where we're at.
Okay. So, just off the top of my head, I've got a few that I've written down here, so I may jump just a little bit, but, so you talked about, having maybe a regional, center that we monitor in addition to Texas. So I think a real big question would be about cybersecurity. Just our own network here, we get hit, I don't know how many hundred times a given day of people trying to break into our little Jerome County network. So what can you tell us about your cybersecurity?
We'll talk about Fort York and LTX.
Yeah, well, first of all, you're wise to think of these things because Washoe County just got hit, and we've gotten about $100,000 in invoices for permits that, you know, that somebody got a hold of their email account and sent those things out. So for our things specifically, we have a couple of different layers. First of all, there's the Federal Energy Regulatory Commission has critical energy infrastructure rules. So all of this is subject to FERC CEI rules, which require a minimum level of internet security. It requires robust, hack-proof operations at the ROC, and also any regional center that we would have here would also be subject to that. And then our communication links to and from the individual projects, those are usually cell phone or satellite links, and those are encrypted. So we have minimum cybersecurity requirements that are mandated by the federal government of the United States. But the other thing is too, we're part of a European company, and their cybersecurity rules are even more strict than what we're required to follow here in the United States. So we have an additional layer of cybersecurity on top of that, which makes it difficult for David and I to share files and things like that. But the point is it protects our technology and the electronic access to these projects very thoroughly.
Okay. So you've got other projects going on. Have you got anything else going on currently in Idaho? Anything pending, anything approved?
Nothing approved as of this point. We had some projects that were pending. Regretfully, they were on BLM land in a different county, and we got some bad interconnection results from Idaho Power. So we've decided not to move forward with those. So we don't have anything specific on the bulletin board for Idaho as we sit here today. But this is someplace that we're very interested to work, and that's why we wanted to come and visit with you folks today. So you're well located for energy projects, and as Aaron pointed out, you know, Idaho Power has a tremendous need. So this is the type of county we would definitely be looking at to locate projects.
So would you work for whoever hired you? Like, are you looking specifically to go with Idaho Power?
That's really kind of our only
Or with
option.
somebody else?
Yeah, and in what we call regulated markets, like the state of Idaho, that's not part of a regional transmission organization like CAISO or SPP, each of the individual utilities is really lord and master of their own service territory. They are really the only people who are legally allowed to sell retail power to customers in this particular jurisdiction. So they being Idaho Power for your region, are almost our exclusive option for off-takers. Now, we can do, and we have done, behind-the-meter projects for large industrial projects, like for example, in hydrous ammonia plants. We've done a facility to support those operations, and that was entirely behind the meter. So essentially, we didn't have a direct utility interconnection except as a backup, and we provided, that reserve power for the industrial.
So who